Okay, guys, just a quick reminder again. I'm going pretty quickly on this. Hopefully, you've had time to try to recreate triangle B prime, I prime, G prime, and hopefully you've recognized if you do this correctly, these points do in fact flip around. So -2, 0 ends up down here at 0, -2. -1, -2 ends up here at -2, -1. And of course B ends up at -2, -4, which was just reversing the coordinates. So we've kind of talked about it. Now I want to get a rule for it. I put it up here in this case. The rule, the function rule for any reflection into the line y equals x, and this only works for the line y equals x. It doesn't work if I had like y equals 2x plus 1. This would not work. You'd have to go find a line perpendicular to 2x plus 1 by doing opposite reciprocal slope, and you'd have to do it a different way. This works for any diagonal line, you know, y equals x. The coordinates x, y just switch, and the x coordinate becomes the y coordinate, becomes the first coordinate, and the y coordinate becomes the x coordinate. They just reverse. So if I told you, hey, reflect 10, 7 into this line y equals x, you could quickly go, hey, that's 7, 10. If I told you to reflect -50, 1, you just change it around. Now it's 1, -50. That's the idea. You can do this now with a rule. You can do it graphically using perpendicular lines and the concept of them bisecting on here. You can do it visually. There is this question on your paper, and it's a very important question. How does P prime, it's very small in here, relate to the mirror line? How does a point connected with its image relate to the mirror line? I asked it before and didn't have you write anything down. Now I want you to write that down. It's very important to actually comprehending what a reflection is. And the idea is that the mirror, two things. The mirror is perpendicular to every point and its image. That's the first thing. And the second part of that is it's bisecting that. The mirror is cutting that in half. In other words, the distance into the mirror is the same as the distance out of the mirror. Unlike if you look at your rear view mirrors on your car, your side view mirrors on your car, they have that little bold-faced writing that says objects appear closer than they are or something like that. This doesn't happen in real reflections. This distance in is the same as the distance out. 1.5 diagonals in is 1.5 diagonals out. It's the same equidistant on both sides. So the reason I have that is on the hey, quiet Homer, is I want you to write a definition for the word reflection. And that's sort of the big part in your paper. I'm going to show you mine. I strongly suggest, and in the other classes I gave them about 2 minutes just to write stuff down. So I want you to pause this thing for a minute or two, whatever it takes you. Write some stuff down, how to define the word reflection. There is no definition in your textbook that's going to do what we're trying to do right here. But it relates to what you just wrote down about P prime and the mirror line. It's going to have some similar words in there. Now that was about 5 seconds. Hopefully you write for another minute on here, and then you pause this thing, write for a minute, and then look back in here. And don't just copy my definition word for word. Steal some words out of it and put it into your own words. Really important that you can verbalize what a reflection really is. One thing I have in here is that the size and shape doesn't change. So I have the word isometric in there. Again, try it on your own first. One thing I also mentioned in there is the fact that there's a mirror line. It's flipping over a mirror line. I'd use the word across. You could certainly, it's flipping, or it's, I don't know, another better word for that. Flipping, folding over a mirror line, another way of saying that. And you could call the mirror line an axis of symmetry if you want. Nothing wrong with that from Algebra 1. And then I'm going to describe specifically the mirror line. The mirror line cuts, first of all, it's perpendicular to the images and the pre-images, and also it bisects each one of those. So somewhere in your definition, hopefully you had the word perpendicular or bisect in there. And it bisects a segment joining a pre-image to its image. That's how I'm finishing this out. So that is not a textbook definition. I just put it into my own words. I encourage you to steal some bits and pieces of this to supplement whatever part of the definition you have on your paper in your own words, in your own thoughts. The last thing on your paper is these quick little examples here. I think you can do this fast. You might get stuck on one of these. The idea is you don't have to graph these. You could certainly do a sketch of a graph, But you don't have to. If you know the rules on here, if you know the rules for reflecting to the x-axis, this is quick. So again, I'll let you go work for a second, and I'll be back in a moment. So, hopefully I had a chance to knock these out pretty quickly. If you're reflecting to the x-axis, the only thing that changes is the y. Hopefully realize the y becomes positive. So there's the rule. In terms of your homework, like showing work on your homework, showing work is either you graph it or you demonstrate what rule you're applying on there. So the rule is y changes. There's my answer, -6, 7. Reflection to the y-axis, well that means the x changes. So I would just show that the x sign changes on there. And I've got -8, 2. Reflection into the line y equals x is just where the coordinates reverse. So I would show that rule where the coordinates reverse. And of course it's 3, -5. So the answers are pretty quick. Make sure you're showing some sort of justification for why this is the right answer. And then you get to the last one, where there is no rule that you know right now. I would recommend you come up with a drawing, a graph at that point. And this is a beautiful graph on a piece of scratch paper here. Move it over here maybe, I don't know. Closer. Yeah, closer works better. There's the line y equals 5. Here's my x-axis. Y equals 5 has no slope, but it has an intercept of 5. So it's up 1, 2, 3, 4, 5, horizontal line. There was the 2, 7 that was given. 2, 7 is up here. All you really got to do is think about it. If you're reflecting into this line, how far from the mirror is it? It's 2 units away. So it's going to be 2 units away down here, and then the coordinates at that point. So it's a vertical reflection. Come on, Mr. Ash, show your work on here. So this is what you're going to do on your paper for homework if you have any like this. And I think there's a couple like this where you're going to have to draw a quick sketch of a graph to be able to finish these off logically and show what you're doing. I'm at 2, 3 now. So I went 2 down, I'm going another 2 down, I flipped over on there. I'm perpendicular to the mirror, and I'm also being bisected by the mirror to create that image. So when in doubt, graph it out, right? When in doubt, graph it out. Hopefully that helps you. You guys should have some time to get this homework done in class. And I know you guys are diligent students, overachieving students. Just follow the leadership of Liam and Daniel Bliss and get this work done. Have a good day, guys.